we're going to have a chat firstly with Phil. Phil Renshaw. His bio's on there, so I'm not going to labour that. We'll have a little chat with Phil. What can you tell us about your background a little bit first, Phil? Your engineering background.
So thanks, and hello to everybody. I started off as an aircraft technician in the British Army in a long time ago now, actually. So I've been around helicopters for all of my military career. So obviously we were quite engaged with balance and rotor vibrations and things like that, because helicopters tend to vibrate. So that kind of led me naturally into what this motion amplification technology can show. And since I've left the military and worked in nuclear and now in the chemical industry, what I've moved towards is trying to improve maintenance and reliability in those plants that I've worked in. So when I got the opportunity to get RMS guys out to plant to show how this thing works, it was a real game changer for me, having spent many years with stroboscopes and flag tracking and things like that, and rotor tuner technologies to actually visualize that quickly was amazing. So a real game changer.
Let me ask you then, Phil. I know you've told me at your plant, we can see it there, is in terms of reliability, maintenance reliability, the focus that they've got in maintenance and their approach to it at your plant has been transformational, hasn't it, over the last 18 months? So I was wondering if you could just give us a bit of a describe what it was like when you arrived at this new site to you. What was it? What was the attitudes like? What was the culture like? And how was the reliability on there?
Yeah. So I mean, there's a couple of phrases which have been banned over the last 18 months, which I'll talk about in a minute. But the culture was, and to an extent, is very much, if it isn't broke, don't fix it. We'll fix it when it fails. When it does fail, stick a bit of duct tape on it and run it again. And when it fails again, do the same thing again and just keep the plant running. And the plant's been operated like that for a significant time, really. And therefore, people fall into bad habits and everything's rushed and there's no time taken over, quality of installation, commissioning work and things like that. So my focus really was about getting back to basics and about addressing that culture of reactive firefighting mentality. And really the whole thing about the plant has been about the cultural change, not necessarily the technology, although the technology has obviously helped massively.
Well, I say there's a lot of different technologies that people would usually go for first, aren't there? Whereas motion amplification is quite advanced in terms of so new, isn't it? What made you think that, right, well, I'll sidestep those things straight away and go straight for MA? What was it that kind of go along those lines?
Well, one of the things I think that most engineers will agree with, and probably the struggle you have is investment and funding. So if I stand in front of the board and say, okay, so I need to spend X amount of $1,000 on this piece of technology or this piece of equipment because the frequency at 15 hertz is too high and it's 40 millimeters per second squared, I might as well be talking in a different language to them entirely, because I really am. But if I can put a video clip up there, the 1920s horror show, as we call it, I can show them immediately what the problem is, and literally as soon as I've put these videos up in front of requests for funds, it's been granted almost immediately. It's such a powerful way of demonstrating what's going on the plant. Not just that, not just with trying to seek funding, but also with the guys as well. So that the operators
help get engagement, involvement.
Yeah. So I've taken operators out onto the plant with the technology, and set up the camera with them and said, okay, so you're complaining about this pump always failing. So let's show you why it's always failing. Put the camera on, and literally within 10 minutes, they are blown away with what they can see. Oh, I didn't realize that wasn't bolted down. I didn't realize that was like that. I didn't realize that the base was flexing that much. All those kind of things, and it makes a real difference, and it makes them think about, even basic things like torque loading bolts and like making sure alignment's good, making sure the actual installation's been conducted properly. It's been quite surprising coming from an aviation background and going into a different industry,
Yeah.
you know, for example, when I arrived on site 18 months ago, we had one torque wrench. I could not get my head around that.
That's crazy, isn't it?
So being able to show, what's actually happening on the plant in real time is a massively powerful tool.
Yeah,
I
remember you actually saying as well, you had the little phrase about helicopter analogy. You said, do you remember that, about the bolts coming loose on it? Does that ring any bells?
Yeah, so I mean, in aviation, obviously, and for those people who have come from that background, vibration when you're flying is not. Some of it is okay. It's going to happen. It's going to vibrate. Helicopters vibrate. It's what they do. But if you let something vibrate to the point where things are starting to loosen themselves off, which does happen, sooner or later you're going to lose something critical. And when you do, unfortunately, in aviation, that tends to result in a fairly significant fatal accident. On plant, what it'll lead to is the significant and catastrophic failure of a system. Hopefully, not injure anybody, but potentially could be. So, not torque loading things, not bolting things down correctly, not following an installation guide, eventually is going to wear your plant out. And the good thing about the technology is being able to demonstrate that really, really quickly. So we use it for commissioning now. We use it for a lot of things where, if we're not sure about something, we can go out and just check it. And certainly where we've had contractors on site who've installed new equipment, we're straight out there with a camera. So that's installed, is it? Okay, let's put the camera on it and let's have a look, see what's happening. So and we can get things rectified immediately.
You've got that with your team now where they want to go and they want to get the camera and look at something and see what the result of the work is, isn't it?
Yeah, I mean, we've used it quite regularly on site, and actually, we've had consultants who come and help us out with projects and stuff like that, and they've seen the technology as well. So, actually, I've been asked to go and look at other sites to give them a hand when they've had an issue. Through our customers and suppliers have said, "Oh, we've got a bit of a problem. Would you mind if you just came and had a look?" And obviously, Stu's seen some of that work that we've done, and I do share regularly with the guys from RMS and other sites to sort of say, look, we've spotted this, just to share it out and show people what's going on.
That's cool. It's brought us on nicely, actually, because you've got one to show us today, haven't you? These R10 pumps. Do you want to talk us through what goes on here?
Yeah, so basically we had a problem with these circulation pumps on two of our reactors, R10 and 11. So this is before we did any work. So what you can see is a lot of pipework movement. The base is actually flexing underneath the motor and moving. It was basically just thrown onto some steel and then that's it. And you can see the frame moving and everything else as well. There's issues with alignment. The whole things were going all over the place, and we were changing couplings every 4 weeks on R10. So it was costing us, an amount of money. So once we highlighted that, we then put in a request for some funds, which we got, and this is what it looks like now. So we've got new bases down, we've mounted the pumps properly, we've aligned everything, we've strengthened pipework supports, we aligned the pipework properly. The only thing that's moving now is some small bore pipework, which we're also fixing on the sample port. But the level of vibration and the level of failure that we've reduced is massively significant. Going from changing that coupling on that pump and motor unit every 4 weeks to, running it for 6-8 months without doing anything to it, pretty much, other than standard routine maintenance, is massively significant in terms of your engineering hours and your operator hours. 4 hours to change a coupling, and we're saving that every 4 weeks, and that's 4 hours we can use elsewhere. So cool. And then being able to demonstrate that back to the company and say, okay, so you gave me this money to do this work, and here's the results, and this is how much time we've saved. So that's really important.
That after shots that you've got there, that being able to look at it afterwards is a real killer, isn't it? To just show that actually, yes, we do these works, we do it properly, and these the evidence to show that it has improved it. Yeah,
and as Stu said, in his case studies there, if there's nothing to amplify, it can't amplify it. So if it's if there is no movement, if the thing's installed correctly and there's no problems with it, you can't just make it move. There's got to be some movement there for it to be amplified. Yeah. So it's it's been a huge improvement on our site. And like I say, it's not just the engineering team. For me, reliability is a team sport. Everybody's involved in it. So we've had operators out, we've had the plant managers out, and we've shown them the issues, and then they've worked with us to help us get the work done. So it's a really great technology to sort of get things started as well.
Yeah, thanks. So we just got 1 minute there. Let me ask you for the last minute, what kind of tips would you give for the guys out there watching today? How could they start implementing it? What kind of top tips have you got to help them get using MA and getting it on site and getting it accepted in the minds of the people who work there, the maintenance crew, and also the management?
So I think I'll go back to maybe the approach that I took was quite good. What I actually did is, instead of going out and investing in the technology, which is for some people is quite expensive, is getting the specialists. Get people in who've got this technology, even if it's a mate of a mate who's got it at a different site, such as me. Get them in to demonstrate it on one of your really bad actors that you think there's a vibration problem or there's another problem, and then show your staff, your engineers and your operators what's going on with the equipment. It'll make a massive difference immediately to be able to show what's going wrong.
Yeah.
And once people see it, it can't be unseen. It's really that powerful. So that's what I'd say. I think what you've got to do is address the real sort of reactive element and I've always done it this way. And these are the phrases that we've banned, which is we've always done it this way and can't.
Yeah.
Because I'll go back to my military days. Can't means won't means jail. So there's always a way of finding a better way of doing something, unless you've really nailed it. So that would really be my advice. Would be get somebody in, get some of your real bad actors visualized, demonstrate that around everybody, and then let them get to it, and they'll make decisions really quickly.
Beautiful. Thanks very much, Phil.
Thanks.
So you heard it there straight from Phil. Free services for MA. If you just put him on LinkedIn, he'll be more than. So that's a good idea. If you want to connect with him on LinkedIn, you can always interact with him directly. Thanks very much, Phil. Appreciate that.